All right. It's good to be with you today to share some of the results from our 2020 research trials in mint. I think I will share the same sentiment that most people will, in that it would have been great to meet with you in person. I really enjoyed the time that we shared it in Fair Oaks last year at this meeting. Unfortunately, that can't happen, so we still are fortunate to be able to share our research results with you. Just an outline of what I plan to talk about in this presentation. We're going to give an update on our research results from 2020, which included 4 different trials in peppermint. We'll give a couple of general updates at the end and then talk about some of the research that's planned for 2021. All right, first things first, we're going to talk about some of the greenhouse work. And I say greenhouse work because in 2020, about the time the pandemic was getting started and closures were happening, the mint research that we had planned was not at that time considered, I don't know what the right term, critical research, I guess, is what we were calling it at the time. And so we missed the window where we would have applied our dormant applications in a field setting. So that being said, we got some work done in the greenhouse. You're familiar with the herbicides that are labeled for mint in the Midwest, and although there appear to be a lot of them, we have a heavy reliance on just a few herbicide groups. So when we rotate herbicides to try to mitigate the effects of or the potential for herbicide resistance, some of the things that we do is to try to rotate through modes of action. And you can see on the screen the herbicides labeled in mint in the Midwest. And we have a heavy reliance on group 5 and 6, which are the photosystem 2 inhibitors. The group 1s, which are the ACCAs or grass selective herbicides. And then maybe you could throw in something like paraquat or Valor, which is flumioxazin, which gets you 2 other modes of action. But for the most part, we have a heavy reliance on the same modes of action. So trying to find herbicides that have different modes of action are certainly useful. Move my video here. So the one that we're going to talk about is peroxysulfone. That's the active ingredient found in the herbicide Zidua. So it's a group 15 mode of action, which is different from what are currently labeled in mint in the Midwest. Now, it is labeled for use in mint in the Pacific Northwestern states at a rate of 1.85 ounces to the acre applied to dormant established mint. However, it does not have a label in the Midwest yet. So we're trying to get some more data to support a registration in the Midwest. There has been a lot of work done with it, but not a whole lot of not a lot of in-depth work, I guess, not a lot of rate effect or dose response type of work, which is what we were planning and what we did in the greenhouse. This work was done by Mallory Smith, and my graduate student made this slide, and she put the rates of peroxysulfone or Zidua in the blue box there. At the time, this was called KIH 485. That was the experimental name of the herbicide. But you can see that the researchers there used 2 different rates, 1.73 ounces to the acre and 3.47 ounces to the acre, and applied it at a few different timings. So we'll go ahead and advance the slides here so you can see pre-emergence, which was applied November 14th when the mint plants were a 1/4 inch tall, which would have been a February 22nd application, and then 2 inch tall mint on April 16th, mid-April there. And essentially what they found was that, of course, the higher rates had more injury. So you can see that here, for example, 20% injury compared to 6.7. And the same thing's true for the pre-emergence, slightly more injury with a higher rate. You would expect that, right? What they also noticed was that there was more injury when it was applied pre-emergence or when the mint was a 1/4 inch tall compared to mint that was 2 inches tall. So kind of a delayed pre-scenario actually resulted in less injury to the mint than pre-emergence application. So the objective of this study was to look at a dose response effect of peroxysulfone or Zidua in what we're calling newly planted peppermint. We'll show you what that looks like here. So I say we, in December of 2019, I went to one of Greg Caney's fields just outside of Rensselaer and dug up some redefined Murray Mitcham mint. We put it in a cooler. It was actually stored in buckets, plastic buckets with lids, put in a cooler that was 40 degrees Fahrenheit until after winter break when we can get around to planting some of it in the greenhouse. When we did, my graduate student and I cut it up into, cut the rhizomes up into segments and put 2 into 8-inch pots containing a mixture of sand and potting soil. With 2 runs, the first one was started on January 21st, and the second one was started on February 3rd of 2020. This is what the 2 rhizomes essentially look like before we covered them with 3/4 of an inch of more substrate. So the rhizomes are 4 to 6 inches long, put 2 of them in an 8-inch pot and covered them with 3/4 of an inch of potting mix and sand in a 1-to-1 ratio. The treatments were applied in a spray chamber in the Lilly facility just down the road from the horticulture greenhouse. We used a randomized complete block with 4 replications. I'll show you, this is a video of what that spray chamber looked like. But we used 5 rates. So we had a 0, which is a non-treated check. Our 1X rate was the rate that's registered for use in the Pacific Northwest states, that 1.85 ounces to the acre. And then we did several other high rates. So a 2X rate, a 4X rate, and an 8X rate. And the idea here is we're trying to see where the crop tolerance breaks. One of the reasons that Zidua is not labeled for use in the Midwestern states was there was a trial in the Midwest where I think it was a 3X rate was injurious to peppermint. So we're trying to figure out at what point that the crop tolerance kind of breaks down for us. So we applied those rates at 1 day after planting. So that would be before the rhizome had sprouted and put up shoots. 2 weeks after planting and 4 weeks after planting. And we harvested 63 days after planting. Some of the crop injury that we saw was some leaf distortion and some leaf necrosis. We kind of thought that this was related to chilling injury initially, but it seems like it was actually related to the application of peroxysulfone. So you can see the necrosis or dead tissue on the left photo really well, and then the leaf distortion in both of the photos. This gives you an idea at 28 days, so before we made our 3rd application, what the pots look like. You can see some of them had 1 rhizome that was growing really well and 1 that didn't. Some had 2 that were growing really well. But you can see the yellow tags there designated untreated pots and what an untreated pot might look like. Applications that were made 1 day after planting, so before emergence, 2 weeks after planting, just to give you an idea of what the effect of treatment was on the crop here. All right, so we'll move on to the data. This is looking at injury 6 weeks after planting. So we didn't see any difference in our application timing for this injury rating. So what we did was we looked at the effect of peroxysulfone rate over all 3 application timings. So rate is on the bottom here, so you can see our different rates. And this is in ounces of product per acre. And then injury on a scale of 0 to 100. So 0 would be no injury, the plant looks fine and healthy. 100% would mean that the plant was completely dead. So we want injury that's closer to 0 than to 100. And in general, what we tend to think is that about a 10% injury is generally going to be acceptable to everyone. So that yellow line is supposed to be at 10%. It's not quite there, but this gives you an idea of where we can be at 6 weeks after planting and have 10% injury or less, and it's around the 3 ounce per acre. All right, so this would be injury at harvest, and we did see a difference in application timing here. So this is the 1 day after planting treatment, and for the most part, you can see that Let's see if we got lines that pop up here. So there'd be 10% injury. You know, you can be at 5 ounces to the acre of product in theory before we would get to the point where we have 10% injury at harvest. The same thing, looking at the same 10% here, you'd have to be probably under about 2 ounces to the acre to, if it's applied at 2 or 4 weeks after planting, to stay under that 10% injury threshold. All right, so this is a photo of what the pots look like at harvest. Of course, you can see one of the high rates here up front. That would be an example of 100% injury. That plant is completely dead. All right, so looking at the plant height at harvest, you can see again rate here on the bottom axis, and essentially those that were not treated were about 40 centimeters tall, and as we increased herbicide rate, we saw a reduction in mid height. All right, this gives you an example of what some of the injury symptoms look like one day after planting. This would be applications made one day after planting, but injury rated at 2 weeks after we planted. So this would be the non-treated check, the 1x rate, the 2x, the 4x, and then the 8x. And of course, this is just a good visual representation of how, as we increase peroxysulfone residual rate, we see more crop injury. All right, moving on, this is the shoot number at harvest, so seeing what impact our treatments have on shoot number. We saw a difference in response the first time we ran the study compared to the second time. So that's what these two graphs show, the differences in response from the first run of the study and then the second run of the study. And essentially what you can see for the first run was that we had a more significant or more steep reduction in shoot number with our 1x rate compared to our non-treated. We didn't really see that same effect in run 2. It wasn't as great a decline in our 1x rate compared to our non-treated. The difference that what we think might be happening here was the quality of the starting material or the propagation material that was utilized. In run 1, we typically had one rhizome that was fairly unbranched and maybe not terribly vigorous, and then one that was branched and really kind of primed to grow. And in run 2, when we put 2 rhizomes in the pot, both of them looked like the image that you can see on the left there. So there may be some component of plant quality in effect here. Okay, looking at shoot dry weight at harvest, so this would be similar to, you know, hay weight, I suppose. So the x-axis again is rate in ounces to the acre, and then this is dry weight on a number of grams in that 8-inch pot is what we're reporting here. So this is for run 1 only, and you can see about 7 grams after it's been harvested, and then we put it in a dryer for about 60 hours to get dry weight. So there would be the non-treated, about 7 grams per pot, and you can see we drop below 5 with the 1x, and then we keep dropping to below about 2 grams at our highest rate. So this would be for run 2. So the second time we did it, we had differences based on when we applied the herbicide. So if it was applied one day after planting, we had this response on the left, in which really the 1x and the 2x didn't have that much of a reduction in biomass compared to the 4 and the 8x. However, with applications made in the second run of the study at 2 and 4 weeks, we did see a drop off from the non-treated control to the 1x as far as shoot dry weight goes. Now, I will say we did, we have extracted oil from these samples, but it's such a small amount of plant material that I don't know if we'll see differences when we run the statistics or not. So even though you all know that just because you have a reduction in hay yield or above ground plant biomass doesn't necessarily mean that it's going to translate into a reduction in oil yield. So, so I don't know how worried we are about these results, but something we certainly should try to validate in the field setting. All right, so in summary for this one study, when 0 to 14.8 ounces of Zidua were applied to newly planted mint, we observed injury that affected plant height, shoot number, and dry weight. And applying it at either 2 or 4 weeks after planting is not recommended, which is different from work that was done by Mallory Smith in the Pacific Northwest. Newly planted mint might be tolerant to low rates of peroxysulfone applied 1 day after planting if it's high quality propagation material. So that's based on the data from this greenhouse study. We'll move on to another Zidua study, this time looking at Zidua applied after harvest and then applied to a simulated dormant mint, which is what the label specifies, the Pacific Northwest label. Right, so this is a little complicated here on the screen, but it gives you an idea of how the studies were initiated. So in our post-harvest study, this is was propagated, as in the last study, using 2 rhizomes that were in that 4 to 6 inch range. And then the plants were allowed to grow, and the above ground plant material was removed 134 days after planting for run 1 and 128 days after planting for run 2. And then we made applications with the same booth sprayer that we used in the study we just showed you. So for the dormant study, we propagated these by stem cuttings instead of rhizomes. 4 cuttings to a pot. Again, the cuttings were somewhere between 4 to 6 inches long each. They were allowed to grow for 97 days before we cut them back and put them in a cooler at 40 degrees Fahrenheit or 4 degrees Celsius for a little over a month to try to induce some kind of something that may look like dormancy that I would see in the field. And again, applications are made in a spray booth. This is what the 2 different pots or 2 different types of starting material look like. Of course, the rhizomes on the left and the stem tip cuttings on the right. We'll move into the post-harvest study. So this would be injury 2 weeks after planting, pooled across both runs of that study. And as you might expect, as we increase peroxysulfone rate, residual rate, we get more injury from our study here. So the 10 bar didn't quite show up for some reason. It's down there on the bottom left of the screen. But if you look at about 10% injury, if we think that that is acceptable as our threshold, you can go to about 2 ounces of residual to the acre before you get 10% injury at 2 weeks after treatment. All right, so this would be injury at 5 weeks after planting, and we had a difference in response for both runs of the study. And so essentially what we have here is, so if you look at the maximum amount of injury here, we're up around 50% at 2 weeks. And you can see for both runs, now we're at 20% and less. So even though there was injury early on in the study, what we're starting to see in this next slide is that the injury is going away. Run 1 is the green line there. Run 2 is the orange line. And like I said, if we put a line at 10% injury, which is kind of a threshold we might say is acceptable, you can see that we'd have to be up around 11 ounces of product now to the acre to get 10% injury in run 1. And then run 2 here, you'd have to be closer to 15 ounces to the acre to get 10% injury. So not a lot of injury at 5 weeks after planting. As far as height goes, so this is height measured in centimeters. You can see, again, we had a difference in response between our 2 runs. So the first run is green line there. Second run is the orange line. And essentially what we see is that there's a linear response here in run 2, but so not too much difference in plant height. And even in run 1, where there seems to be a steep drop off between the 4 and the 8x, there's not a ton of difference between the 0 and the 4x right here. So not a ton of response to plant height from our low rates of Zidua. This gives you an example of what the plants look like at harvest. So you can make out some differences perhaps, but for the most part, they all look really similar to the non-treated check. However, when we did take dry weight, so we took all the above ground plant matter measured fresh weight, put it in a dryer, and dried it for about 2.5 or 3 days. This is what the dry weight looked like. So this again is grams per 8-inch pot. So you can see differences from run 1 and run 2. Essentially, the trend is really the same, though, in that there was kind of this gradual decrease in dry weight as we increased our rate from 0 to 15 ounces, essentially, to the acre. All right, moving on to results for the dormant study. Again, our rate is on the bottom here, and this is injury at 2 weeks, pulled across both of our runs, run 1 and run 2. And what you'll see is that we do, again, see a rate response here, which is what we're supposed to see, going from 0 to about 30% injury at our highest rate. So if we wanted to, again, say 10% is an acceptable threshold, we'd have to be somewhere around 1.5 ounces to the acre to have less than 10% injury at 2 weeks after treatment. All right, so this would be injury at 4 weeks after treatment. Again, differences in response from our first run and our second run. And what you'll notice is that to get about 10% injury, we would have to be at around 9 ounces for run 1, which is well over the labeled rate of 1.85 ounces. And then in the second run, we could have about 4 ounces to the acre of product and still be below 10% injury at 4 weeks. So we're seeing essentially a similar response in that the injury is not persistent. The injury we saw 2 weeks after treatment that went up to 30% at the highest rate is now somewhere around 20% at our highest rates. So the injury is not persistent, and we can actually put on several times the labeled rate and have an acceptable amount of injury 4 weeks after treatment. Not that we would do that, but it's good to know that we've got that buffer. So this is injury at 6 weeks after treatment. You can see again a really difference in the response between our first and second runs of this study. In the first run, we're sitting at 0% injury at 6 weeks until the very highest rate. It's not necessarily true in the second run. At the 2x rate here, we do start to see an increase in injury. But even so, look at the scale here on this left or upright or y-axis. Tops out at 10, right? So even though it looks dramatic, pretty much all of these injuries are less than 10%. All right, so we'll move on. So this will be plant height at 2 weeks after treatment. Again, differences in response between the 2 runs of the study. And what you'll see is that for run 1, again, we have to really get to this high rate before we see any reduction in plant height at 2 weeks. And we see a pretty gradual decline in plant height with our second run, of course, bottoming out with our highest rate. And pretty much the exact same trend was observed at 4 weeks after treatment as well. And then at 6 weeks after treatment, we didn't see a response or a difference between the 2 runs. So this is combined across both the runs. And we have this, what we call a negative linear response to rate, in that as rate increases, plant height decreases. Now, if we look at dry weight, again, differences between run 1 and run 2, but the trends are really quite similar. A gradual decrease in plant dry weight as we increase our herbicide rate. So when we apply 0 to 14.8 ounces per acre of Zidua to established mint and to simulate a dormant mint, we do see increased injury and plant stunting and a reduction in plant dry mass as we increase herbicide rate. But when we apply the 1x rate, the 1.85 ounces to the acre, peroxysulfone resulted in minimal and transient, meaning it didn't persist, injury, and minor reductions in above ground dry weight. So relative to the amount of weed control that the herbicide would provide, this amount of injury doesn't seem like much of a concern, or I wouldn't be too greatly concerned with it. All right, so moving on to the Tyfenicil study. This was a post-harvest study, and most of these slides were prepared by Brandi Woolam, my graduate student, so this is her handiwork. Essentially, what this is, Tyfenicil, if you're familiar with Sharpen, it's really similar to Sharpen, which is saflofenicil, and it is now available as of last fall in 2 different products. So Gamma, which is supposed to be, it's a 70%, I think it's a wettable dry granule. So it's a dry product. It's going to be labeled in grapes. And I think this may be the one that if it gets a mint label, it may be this formulation. We'll just have to see how that goes. And then it's available as a Reviton as well, which is for corn, cotton, soybean, and wheat. That'd be a liquid formulation of the herbicide. The Tyfenicil itself is a class 14 or group 14 herbicide, so it's a PPO. Again, that'd be similar to saflofenicil, which is another PPO. So this study was conducted in, let's see, so stumbling through the slide here, you'll forgive me probably. So essentially we started these 2 runs differently. Again, rhizomes were started for one and stem tip cuttings were started for the other. They were both planted into a 1-to-1 ratio of sand and Metro Mix, again into 8-inch pots and put into the greenhouse facility in West Lafayette, there, the Hort greenhouses. Then we harvested all the above ground plant material at 127 days for run 1 and 69 days after planting for run 2. And then the pots were treated. So kind of trying to simulate an application made after harvest when the ground is pretty bare. Trying to keep weeds suppressed so you get that regrowth without weed competition, essentially is what we're shooting for here. So these applications were made on June 10th and then on August 11th for run 1 and 2 respectively, using the same spray chamber. The rates that we used were 0, which is our non-treated check, and then these are reported in grams active ingredient per hectare. So it'd be 25, which would be essentially a 1x rate, 50, 100, and 200. So again, we've got the same 1x, 2x, 4x, 8x kind of dose response that we're looking for. That's how the magic happens. So it's another shot of the spray booth there. The data that were collected, again, visual crop injury at 14, 28, 49 days after we treated, and plant height at 28 and 49 days after treatment. Then we did harvest the above ground plant biomass and took fresh weight and dried it and collected dry weight data as well. All right, so there was a run by treatment interaction. Data for 14 and 28 days after treatment are presented separately by run. So that's what you'll see here. Both runs presented separately in 2 different graphs this time instead of on the same graph. But essentially what you can see is that we do see a significant amount of injury. Even at our 1x rate, we're up around over 60% injury for run 1 and encroaching on about 20% injury for run 2. Now, that was 14 days after treatment, so 2 weeks after treatment. By 28 days after treatment, we can start to see the bottom of these curves kind of shift a little bit. So what we're seeing essentially is that now, even at a 2x rate, we're not seeing much crop injury at all. We actually have to get up to the 100 gram rate, which would be a 4x rate, before we see any significant injury in run 1. Again, for run 2, the 1x now at 28 days is not showing signs of injury. You have to get to that 2x rate before you start to see injury encroaching on about 20%. So this is what injury at 28 days looks like. You can see not a lot of injury. What we were seeing essentially from this herbicide, and it's similar to what you would see from Sharpen herbicide as well, is that it essentially burns any green tissue that it touches. So any rhizomes that were above the soil surface, stolons, any leaf tissue that might have been left that didn't get removed when we did our simulated harvest, it all had some amount of necrosis or tissue death. But by 28 days, the plants are starting to grow out of that. And that's what these photos are showing you. So let me show you this photo here, for example, would be the highest rate, the 8X, the 4X, the 2X, the 1X rate, and then the non-treated. And what you can see, again, kind of the same thing here, the non-treated, 1X, 2X, 4X, and 8X. Just a classic dose response to herbicide injury, to herbicide rate. By 49 days, this is injury data across both runs. Again, we can see that through the 2X rate, there's not very much injury at all. And now even at the highest rate, this 8X rate, the most injury we're seeing is getting close to maybe 20%. So the injury has subsided. The plants are growing out of the injury that they experienced from this herbicide. Looking at plant height, this is at 28 days after treatment. Again, not much difference between our non-treated check for run 1. And really the 1 and 2X also didn't have much of a response. You had to get to the 4X before you saw a reduction in crop height. Pretty similar response here for run 2 as well. The 0, the 1, and the 2X really similar in their height. And it's by the time you get to the 4 and the 8X where we see any real reduction in crop height here at 28 days after treatment. 49 days after treatment is pretty similar, except that you really 0 through the 4X rates didn't have much of a reduction in plant height. You had to get to this 8X rate down here before you saw a decrease in plant height 48 days after treatment. Looking at dry weight 48 days after treatment, it's a little bit different. We do see a gradual decline in dry weight of the plant material, ranging from our 0 to our 8X rates here. So again, just to show you that although there was injury, the plants grew out of it. You can see with the injury on the top there, it looks like at 14 days after treatment. And again, you can see it's kind of just a general necrosis. Any green plant tissue that existed above the soil surface at the time of application was burned. And then again, you can see what the plants look like at our harvest at 49 days after treatment. There's the check right there on the left, the 1X, 2X, 4X, and 8X. And even though we did see differences in height and dry weight, all of these plants look healthy. All right, so in summary, regrowth at 14 days after treatment was slow compared to the check. However, at 28 days, the rate increased from 25 to 200 grams of active per hectare, which would be again our 1 to 8X rates. Predicted peppermint injury increased and height decreased. And at 49 days after treatment, regrowth was really evident and the plants rebounded quite nicely. All right, we'll move on here. Some general updates. So these next couple slides will be pretty quick. Tough 5EC now, so it's Pyridate, has a Section 3 label that was approved in the state of Indiana on February 5th. So so it had been available to the mint industry and then went off market. And then for the last several years had been available through a Section 18 emergency exemption label. The good news is we won't have to worry about those Section 18 labels as it's on the national label now. So if you look at the new Tough 5EC label that's approved for the state of Indiana, you'll see it has mint, field corn, and chickpea. So really only 3 crops right now. According to the label, you can apply up to 2 applications of 24 fluid ounces of product to the acre with a maximum of 48 ounces per treated acre per year. I think the Section 18 allowed for 1 application of 24 ounces. So this allows for a second application if you deem it necessary. There's still a 49-day pre-harvest interval. So from when you apply it to when you can harvest the mint. However, the previous Section 18 labels had restrictions for which counties could use this and a total allowable amount of acres in the state that could have this product used as well. And the Section 3 label, this specimen or national label now, doesn't have a county or acreage restriction, so that's a good thing. Move on to the last bit here, planned research for 2021. As far as field research trials go, we weren't able to get any in the ground in 2020, but we've got a couple things planned. So Sharpen, which is Tyfenicil, weed scientists in mint have been looking at this product for a decade now. It was selected for residue testing and tolerance trials at the 2020 IR4 Food Use Prioritization Workshop. So essentially, IR4, along with the registrant, is going to fund some research to look at residue and then tolerance trials in Indiana and Wisconsin. So we in Indiana have to put out 2 of those trials. And essentially, we're looking at Sharpen. I think it's at a 1X, a 2X, and a 3X with a non-treated and a grower standard, just to see what it looks like in Indiana. Try to get more data to support a registration for Sharpen in mint. And then the other thing is the MIRC multi-state trial. Those treatments will focus on Sharpen, Zidua, and for the Pacific Northwestern states, I think they may not look at Zidua by itself, but combine it with other herbicides, particularly some of the post-emergence herbicide products that are available. We'll look at Tyfenicil, and then there's also an interest in Star Rain as well, which has kind of a niche efficacy or control of some of the weeds that we might see as we come out of winter, some of the winter annual weeds. We also plan on conducting some greenhouse trials. The greenhouse has been a great resource for us to get mint research conducted year-round. And so looking at maybe dual magnum, it's similar to Zidua, similar mode of action, and then Sharpen, just to try to tease out some dose response work there, and then Star Rain as well, just to complement the field research that we have planned with it in 2021. All right. Well, it's been a pleasure talking to you. If you have any questions, feel free to reach out to me. I look forward to working with you this year and hopefully getting some more herbicides labeled for use in mint in the Midwest. Thank you.